November 7, 1942. Hauptmann Werner Schulze knelt beside the body of an American soldier in the rocky hills east of Oran, Algeria. The fighting had ended hours earlier, but Schulze, a logistics officer with the 10th Panzer Division, had orders to catalogue every piece of American equipment his unit could recover. What he discovered in the next 20 minutes would begin a chain of intelligence reports that would reach the highest levels of Wehrmacht command within days. The dead American soldier wore the uniform of the United States 1st Infantry Division. His Springfield rifle lay beside him. Standard issue. Nothing remarkable. But when Schulze examined the soldier's cartridge belt and bandolier, he stopped counting at 140 rounds. He searched the soldier's pack and found another 80 rounds in stripper clips, 220 rounds of .30 caliber ammunition carried by a single rifleman. Schulze had served on the Eastern Front, where German infantry typically carried 60 rounds for their Mauser rifles, with another 30 in the soldier's pack if logistics permitted. He had fought in France in 1940, where ammunition supply was generous by Wehrmacht standards. Yet even then, German riflemen rarely carried more than 90 rounds into combat. But here was an American private soldier, recently arrived in theatre, carrying nearly 2.5 times the standard German combat load. The mathematics troubled him immediately. If every American rifleman carried 220 rounds, and a typical infantry company fielded approximately 190 riflemen, then American infantry companies entered combat with over 40,000 rounds of rifle ammunition on their soldiers alone. This did not include machine gun ammunition, mortar rounds, or grenades. Just rifle ammunition carried by individual soldiers. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. Schulze ordered his men to search every American casualty and abandoned position they could find. The pattern repeated with disturbing consistency. American soldiers carried between 180 and 240 rounds of .30 caliber ammunition, with 220 rounds appearing most common. Some soldiers carried even more, with bandoliers draped across their chests and pockets stuffed with loose clips. Within 2 days, German technical intelligence teams were examining not just the ammunition quantities, but the ammunition itself. What they discovered went far beyond simple logistics. The Americans had created an entirely new system of infantry firepower based on industrial capacity that Germany could not match. The examination took place at a temporary intelligence facility established in a commandeered French colonial building in Tunis. Oberst Friedrich Hartmann, formerly a munitions expert with the Reich Ministry of Armaments, led the technical team. With him were specialists in metallurgy, ballistics, and military logistics. They began with the most basic question: where did all this ammunition come from? The answer emerged from captured American supply documents and interrogation of prisoners. American ammunition production had reached levels that German planners found literally unbelievable. Lake City Arsenal in Missouri was producing over 500 million rounds of .30 caliber ammunition annually. Frankfurt Arsenal in Philadelphia added another 300 million rounds. Twin Cities, Arsenal in Minnesota, Denver Ordnance Plant in Colorado, and half a dozen other facilities combined to produce over 1.5 billion rounds of small arms ammunition per year. Germany's entire small arms ammunition production across all calibers for all services totaled approximately 1 billion rounds annually. The Americans were producing more .30 caliber rifle ammunition alone than Germany produced of everything combined, and American production was still ramping up, with new facilities coming online monthly. But raw production numbers told only part of the story. The technical examination of captured American .30 caliber ammunition revealed manufacturing sophistication that exceeded anything in German experience. Each cartridge was remarkably consistent. Weights varied by less than 1 grain. Powder charges were uniform. Primers showed identical sensitivity. This was not ammunition hand-loaded by skilled technicians. This was industrial output, where every round was functionally identical to every other round. The brass cartridge cases impressed the German examiners immediately. American cases were drawn from sheet brass, using precision dies that produced cases of absolute uniformity. The brass itself was a copper-zinc alloy of 70% copper and 30% zinc, chosen for its combination of strength, corrosion, resistance, and ease of manufacture. German cases used more complex alloys, with varying compositions depending on availability of raw materials. German ammunition varied noticeably in quality and performance. Cartridges produced at different factories showed different characteristics. Cases from one lot might be slightly longer or shorter than cases from another. Powder charges varied enough that experienced shooters could feel the difference. Primers had sensitivity ranges that affected reliability. This variation reflected Germany's decentralized manufacturing system, where multiple contractors produced components to similar but not identical specifications. American ammunition showed no such variation. A cartridge manufactured at Lake City Arsenal in January performed identically to one made at Frankfurt Arsenal in June. The bullets were interchangeable. The cases were interchangeable. The complete rounds were interchangeable. This level of standardization required industrial organization that Germany had never achieved. The bullet itself revealed even more disturbing facts. American .30 caliber ball ammunition used a 150-grain full metal jacket bullet with a gilding metal jacket over a lead antimony core. The jacket was bonded to the core through a precise manufacturing process that prevented separation on impact. The bullet was boat-tailed, meaning the base tapered slightly to reduce drag and extend range. Every bullet examined showed identical dimensions measured to within 1/1000th of an inch. The ogive, the curved nose of the bullet, followed an exact mathematical profile on every specimen. The cannelure, the groove where the case crimped the bullet, was positioned at precisely the same location on every round. The base of the bullet showed clean, uniform, forming with no defects or irregularities. Lieutenant Hans Dietrich, a ballistics specialist who had worked at Deutsche Waffen- und Munitionsfabriken before the war, spent an entire day measuring captured bullets. He reported that American manufacturing tolerances were tighter than German proofhouse acceptance standards. Every American service round he examined would have been classified as match-grade ammunition in German practice, reserved for snipers and competition shooting. Yet the Americans were issuing this quality of ammunition to every soldier as standard ball ammunition. The powder used in American cartridges posed another puzzle. Chemical analysis revealed a nitrocellulose-based propellant with precise burning characteristics. The powder grains were uniform in size and shape, indicating careful manufacturing and quality control. Moisture content was carefully controlled. The powder was coated with a deterrent chemical that modified burn rate to produce consistent pressure curves across all temperatures. German ammunition used various powder formulations depending on what was available. Powder quality varied between manufacturers and even between production lots from the same manufacturer. Some powder absorbed moisture and degraded in storage. Some burned too fast in hot weather or too slow in cold conditions. Ammunition that worked perfectly in testing sometimes performed erratically in field conditions. The primers particularly interested the German team. American primers used a brass cup, a paper disc anvil, and a priming compound that provided reliable ignition under all conditions. The primers were pressure-formed to exact dimensions, assembled automatically, and tested statistically. Random samples from each production lot were fired to verify sensitivity and power. Each primer examined showed identical construction. The cup thickness measured exactly 0.025 inches. The anvil was positioned at precisely the correct height. The priming compound was distributed evenly. These were not hand-assembled components. These were machine-made parts produced by the millions with perfect consistency. By the end of the first week of examination, Oberst Hauptmann had enough information to draft his initial report to Wehrmacht High Command. The document ran to 40 pages of technical analysis, but the essential conclusions could be stated simply. American ammunition manufacturing represented industrial sophistication that Germany could not match. The Americans had transformed ammunition production from a craft practiced by skilled workers into an automated process performed by machines. More critically, American ammunition quality enabled the high volume of fire that their infantry tactics demanded. If German soldiers fired their weapons conservatively to preserve limited ammunition supplies, American soldiers could fire freely, knowing that resupply was always available. The Americans had built their infantry tactics around the assumption of unlimited ammunition, and their industrial base made that assumption realistic. The report reached Berlin on November 21, 1942. It was classified, secret, and distributed to senior officers in the Oberkommando der Wehrmacht and the Reich Ministry of Armaments. The response was a request for more detailed analysis, focusing on German capacity to match American ammunition production and quality. Hauptmann's team expanded their investigation. They examined captured American supply manifests, transportation documents, and ammunition expenditure records recovered from destroyed American vehicles. What emerged was a picture of a logistics system designed to deliver ammunition in quantities that German planners considered wasteful. American infantry battalions were authorized ammunition allowances that exceeded German divisional reserves. A single American rifle company's basic load of ammunition required more transportation than a German infantry regiment's resupply for a week. The Americans simply assumed that ammunition would always be available, that resupply would always arrive, that no unit would ever run short. German logistics operated under entirely different assumptions. Ammunition was a precious resource to be carefully husbanded. Soldiers fired only when necessary. Machine gunners learned to fire in short bursts to conserve ammunition. Artillery batteries counted shells carefully, knowing that resupply might not arrive for days or weeks. The entire Wehrmacht operated under the constant constraint of limited ammunition. The examination of American packaging revealed another dimension of industrial sophistication. 30-caliber rifle ammunition came in bandoliers holding 48 rounds in 6-round clips. The bandoliers were woven cotton web with pockets that held the clips securely but allowed quick access. Each bandolier was marked with the lot number, date of manufacture, and arsenal of origin. The printing was crisp and clear, applied by machine during manufacturing. The clips themselves were stamped steel of uniform quality. The spring tension was consistent across all specimens examined. The follower that held the cartridges was positioned identically on every clip. These clips were designed to be disposable, used once and discarded. German soldiers were trained to recover and reuse their cartridge clips because new ones were not always available. American ammunition also came in wooden crates, holding 840 rounds in 14 bandoliers. The crates were precision-made from pine lumber, with rope handles for carrying and metal straps for stacking. Each crate was stenciled with complete information about contents, weight, and handling instructions. The crates were standardized so that any soldier could open one, remove bandoliers, and distribute ammunition without confusion. German ammunition packaging varied by manufacturer. Boxes came in different sizes depending on who made them. Labels used different formats. Some boxes required tools to open. The lack of standardization meant that soldiers sometimes struggled to access ammunition even when it was physically present. The German examination team also studied American ammunition distribution systems. Captured documents revealed that American supply officers tracked ammunition by type, lot number, and location. They knew exactly how many rounds of each type were at each supply point. They could calculate consumption rates and predict when resupply would be needed. They used standardized forms, consistent procedures, and systematic record-keeping. German ammunition accounting was more ad hoc. Different units used different systems. Records were often incomplete. Supply officers made decisions based on experience and judgment rather than systematic data. This worked reasonably well in static conditions, but broke down under the chaos of mobile warfare. By December 1942, German forces in North Africa were capturing enough American equipment to perform extensive field testing. One test particularly interested Wehrmacht observers. German soldiers, using captured American rifles and ammunition, conducted firing trials to determine practical accuracy and reliability. The results confirmed what the technical analysis had suggested. American ammunition performed consistently under all conditions tested. Hot desert days, cold desert nights, sand, dust, and rough handling had minimal effect on reliability. The ammunition fed smoothly, fired reliably, and produced consistent velocity and accuracy. German soldiers testing the ammunition reported that they could fire American .30 caliber rifles all day without a single malfunction. Comparative tests using German 7.92mm Mauser ammunition in German rifles showed noticeably more variation. Some lots performed excellently, others showed problems. Cartridges from certain manufacturers were prone to split cases or stuck bullets. Some powder lots produced excessive fouling that required frequent cleaning. The inconsistency reflected Germany's manufacturing reality. The testing program expanded to include examination of American manufacturing documentation. Captured technical manuals revealed the complete specifications for .30 caliber ball ammunition. The manuals included dimensional drawings measured to 4 decimal places, chemical formulas for powder and primer compounds, heat treatment specifications for brass cases, and quality control procedures that tested random samples from every production lot. German ammunition specifications existed, but they were less detailed and less strictly enforced. Manufacturing tolerances were wider. Quality control was less systematic. The Germans relied more on the skill of individual workers and less on process control and statistical testing. This approach worked when production volumes were modest but could not scale to American levels. Lieutenant Dietrich, the ballistics specialist, wrote a supplementary report focusing specifically on manufacturing methods. He documented that American ammunition factories used progressive stamping presses that formed cartridge cases in multiple stages automatically. Each case passed through a series of dies that gradually formed it from a flat brass disc to the final tapered cylinder. The entire process was automated, with machines measuring, inspecting, and rejecting defective cases without human intervention. German case manufacturing used similar principles, but less automation. More operations required manual handling. Quality inspection was visual rather than mechanical. Production rates were lower, typically 3,000 to 5,000 cases per hour per press, compared to American rates of 8,000 to 12,000 cases per hour. The bullet manufacturing process showed even greater disparity. American facilities used automatic machines that formed lead wire into cores, swaged cores to exact weight, drew jackets from gilding metal, assembled cores and jackets, and swaged the complete bullet to final dimensions. A single machine could produce 6,000 bullets per hour with consistent quality. German bullet production involved more manual operations. Cores were cast in molds, not swaged from wire. Jackets required separate forming operations. Assembly of cores and jackets needed skilled workers. Final forming was less precise. Production rates rarely exceeded 2,000 bullets per hour, and quality varied depending on operator skill. The powder manufacturing and loading process revealed similar patterns. American facilities used continuous process equipment that mixed chemicals, formed grains, dried powder, and coated grains with deterrents in automated sequences. The powder was then loaded into cartridge cases using volumetric measures calibrated to deliver exact charges. Statistical process control ensured consistent powder weights across production lots. German powder manufacturing was more batch-oriented. Mixing was done in smaller quantities. Grain forming used slower processes. Quality control relied on testing samples from each batch rather than continuous monitoring. Powder loading used similar volumetric methods, but with less precise calibration and more variation between operators. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. The primer manufacturing process showed the greatest automation disparity. American primer facilities used transfer presses that automatically formed cups, inserted anvils, charged priming compound, and sealed primers in continuous operations running 24 hours daily. A single press line could produce 50,000 primers per hour, with rejection rates below 1%. German primer manufacturing involved more manual operations. Cup forming was automatic, but anvil insertion often required hand placement. Priming compound charging used semi-automatic equipment that needed operator attention. Quality control was sample-based, rather than continuous. Production rates averaged 20,000 primers per hour with higher rejection rates. The complete picture that emerged from months of examination was sobering. American ammunition factories were designed from the ground up for mass production. Every operation was optimized for speed, consistency, and minimal manual intervention. The factories ran multiple shifts, employed tens of thousands of workers, and produced ammunition measured in billions of rounds annually. German ammunition production, while competent and adequate for European warfare, was not designed for the scale of conflict that America was preparing to wage. German factories were smaller, more craft-oriented, and dependent on skilled workers who were increasingly being drafted into combat units. Production was measured in millions, not billions. Quality varied because the system assumed that variation was acceptable. By February 1943, Oberst Hauptmann submitted his comprehensive report on American .30 caliber ammunition. The document exceeded 200 pages and included detailed technical drawings, chemical analyses, manufacturing process descriptions, and strategic assessments. The conclusions were unambiguous. American ammunition manufacturing represented industrial organization that was 5 to 10 years ahead of German capabilities in automation, quality control, and production volume. Germany could not match American output with existing facilities, even if all resources were devoted to ammunition production. More critically, American ammunition quality enabled infantry tactics based on sustained high-volume fire that German logistics could not support. The report estimated that matching American ammunition production would require Germany to build 50 new factories, train 100,000 additional workers, and invest resources equivalent to twice the annual Luftwaffe budget. Even then, Germany lacked access to certain raw materials, particularly high-grade copper for case manufacture, which America imported freely from Chile and other sources. The strategic implications were clear and disturbing. American infantry could fight differently because they had different resources. They could use ammunition freely because resupply was certain. They could employ suppressive fire tactics because running low on ammunition was not a realistic concern. German infantry, constrained by limited ammunition, had to fight more carefully, more conservatively, and ultimately less effectively. The report included specific examples from North African combat. American infantry units regularly expended 500 to 1,000 rounds per rifleman during single engagements. Machine gun crews fired 3,000 to 5,000 rounds per gun per day. These consumption rates would have exhausted German battalion ammunition reserves in hours. American units resupplied daily and never reported ammunition shortages. German units in North Africa operated under constant ammunition constraints. Riflemen were instructed to limit fire to necessary targets. Machine gunners learned to fire in disciplined bursts. Battalion commanders hoarded ammunition reserves, knowing that resupply convoys might not arrive. The tactical flexibility that unlimited ammunition provided to American forces simply did not exist for German troops. The examination of American manufacturing methods also revealed organizational differences that transcended pure technical capability. American ammunition factories were managed using systematic methods borrowed from automotive manufacturing. Production was planned weeks in advance. Materials were ordered based on forecasted demand. Workers were trained using standardized procedures. Quality was measured statistically with control charts and process monitoring. German ammunition production operated more traditionally. Production schedules responded to military requests that often changed weekly. Materials were ordered when available rather than when needed. Workers learned through apprenticeship rather than formal training programs. Quality was assessed through inspection and testing of finished products rather than process control during manufacturing. One captured American document particularly fascinated the German analysts. It was a production schedule from Lake City Arsenal for January through March 1943. The schedule listed daily production targets for different ammunition types, materials required, machine allocations, and quality control checkpoints. The level of detail and precision suggested an organization that had complete mastery of its manufacturing processes. No comparable document existed in German ammunition production. Factories received monthly quotas and delivered what they could based on available materials and workers. Day-to-day production varied significantly. Planning beyond a few weeks was difficult because material supplies were uncertain and priorities changed frequently. The contrast between systematic American planning and improvised German responses was stark. The human dimension of ammunition production also emerged from the intelligence analysis. American ammunition factories employed hundreds of thousands of workers, predominantly women who had entered industrial work for the first time. These workers operated complex machinery after training periods measured in weeks, not years. The machines were designed to be operated by people with minimal technical background, with safety interlocks, automatic adjustments, and simple controls. German ammunition production relied more heavily on skilled workers, predominantly male, who had years of experience in metalworking and manufacturing. As the war progressed and these skilled workers were conscripted into military service, German ammunition quality deteriorated noticeably. The replacement workers, including forced laborers and prisoners, lacked the experience to maintain quality standards. By spring 1943, German forces were encountering American ammunition on multiple fronts. In Tunisia, Sicily, and later Italy, every engagement produced captured American supplies that confirmed the original assessments from North Africa. American soldiers carried enormous quantities of ammunition and used it freely. Resupply was constant and reliable. Quality never varied. The German response to this intelligence was limited by reality. Germany simply could not build 50 new ammunition factories while fighting on multiple fronts. The raw materials, particularly copper and lead, were increasingly scarce. The skilled workers needed for factory construction and operation were fighting in Russia, Italy, and France. The capital investment required exceeded available resources. Some improvements were attempted. German ammunition manufacturers received instructions to tighten quality control and reduce variation between production lots. New machinery was purchased where possible to increase automation and consistency. Production schedules were systematized to provide more predictability. These measures helped, but they could not close the fundamental gap in industrial capacity. The examination of American .30 caliber ammunition also prompted analysis of American small arms doctrine. Captured training manuals revealed that American infantry were taught to use firepower as their primary tactical advantage. Soldiers were trained to fire rapidly and accurately, knowing that ammunition would always be available. Machine gunners learned to sustain fire for extended periods, to suppress enemy positions while riflemen maneuvered. This doctrine contrasted sharply with German infantry tactics, which emphasized maneuver, infiltration, and conservation of ammunition. German soldiers were trained to fire only when they had clear targets. Machine guns provided short bursts to support specific movements rather than sustained suppression. The tactics reflected the logistics that supported them. By summer 1943, German intelligence had documented American ammunition expenditure rates across multiple theaters. In the Pacific, American Marine divisions were expending over 1 million rounds of small arms ammunition per month during active operations. In Italy, American Army divisions consumed similar quantities. The total American ammunition expenditure exceeded German production capacity just for the forces already deployed. The reports flowing back to Berlin included increasingly desperate assessments. Germany was fighting an opponent who could afford to waste ammunition because production was effectively unlimited. American infantry could spray bullets at suspected positions, use suppressive fire liberally, and employ ammunition as a substitute for careful maneuver. German infantry had to make every shot count because resupply was uncertain. The psychological impact on German soldiers who captured American ammunition was noted in after-action reports. German infantry, who obtained American .30 caliber ammunition for captured weapons, reported feeling liberated by the abundance. They could fire more freely, knowing that more ammunition was likely available. The contrast with their normal ammunition situation was demoralizing when they returned to German weapons and German supply systems. One particularly detailed report from Italy in August 1943 described a German company that had captured an American supply dump containing over 200,000 rounds of .30 caliber ammunition. The German soldiers, accustomed to receiving a few hundred rounds per week as resupply, could not comprehend the quantity. The company commander reported that his men initially thought the ammunition was defective or training ammunition because surely combat ammunition would not be stored in such quantities. Testing proved the ammunition was standard combat issue, recently manufactured, and of excellent quality. The German company used the captured ammunition for a week, firing more rounds in 7 days than they typically fired in 2 months. When the captured supply was exhausted and they returned to normal German ammunition allocation, morale dropped noticeably. The soldiers had experienced what unlimited ammunition felt like, and returning to scarcity was psychologically difficult. The technical intelligence teams continued examining American ammunition throughout 1943 and into 1944. Each new lot captured showed incremental improvements. Packaging became more weather-resistant. Marking became clearer. Quality consistency improved further. The Americans were continuously refining their manufacturing processes, even as production volumes increased. German ammunition, in contrast, showed declining quality as the war progressed. Material shortages forced substitution of inferior brass alloys for cases. Powder quality varied more widely. As chemical supplies became uncertain, primers became less reliable as production was dispersed to smaller facilities to avoid bombing. By late 1944, German soldiers noticed that their ammunition was not as reliable as it had been earlier in the war. The bombing of German ammunition factories accelerated this decline. Raids on manufacturing facilities in the Ruhr, Silesia, and Saxony destroyed production capacity that could not be replaced. Dispersal of production to smaller facilities and underground locations reduced efficiency and quality. The systematic American approach to ammunition manufacturing, with its multiple large facilities and standardized processes, proved more resilient to strategic bombing than Germany's more fragmented system. By January 1944, over a year after the first examinations in Tunisia, German technical intelligence had compiled a comprehensive understanding of American ammunition manufacturing. The reports filled filing cabinets in Berlin with detailed analysis of every aspect of American production. The conclusions never changed. American industrial capacity had made ammunition abundance a reality that fundamentally altered infantry combat. The introduction of American semi-automatic rifles added another dimension to the ammunition advantage. The M1 Garand rifle, which became standard American issue by mid-1943, fired 8 rounds as fast as the soldier could pull the trigger. Combined with the 220-round basic load, American riflemen could deliver firepower that approached German squad automatic weapons while remaining mobile infantry. German intelligence quickly recognized the implications. A single American infantry squad with 8 M1 rifles could deliver sustained rapid fire that exceeded a German infantry squad's combined firepower, including their machine gun. The abundance of ammunition made this firepower practical rather than theoretical. American soldiers could actually fire their rifles rapidly because resupply was certain. Comparative ammunition expenditure data collected from prisoner interrogations and captured documents revealed the disparity in stark numbers. An American infantry division in active combat expended approximately 1.5 million rounds of small arms ammunition monthly. A German infantry division typically received 500,000 rounds monthly, and that allocation was often not met due to supply difficulties. American divisions were firing 3 times as much ammunition and receiving it reliably. German divisions fired less and often ran short. The tactical implications were obvious to every soldier who experienced the difference. American positions erupted with overwhelming fire at the slightest contact. German positions responded with measured, careful fire to conserve limited ammunition. The German technical teams also examined American ammunition logistics beyond manufacturing. They studied the transportation systems, storage facilities, and distribution methods that moved billions of rounds from factories to frontline soldiers. What they found was another dimension of American industrial organization that Germany could not match. American ammunition moved from factories to ports in dedicated trains with priority routing. It crossed oceans in ships specifically configured for ammunition transport with proper magazine storage and handling equipment. It moved from ports to forward supply dumps in trucks organized into transportation companies dedicated to ammunition hauling. At every stage, the ammunition was tracked, inventoried, and protected. German ammunition logistics were more improvisational. Ammunition shared transportation with other supplies based on priority and availability. Tracking was less systematic. Storage was often inadequate, leading to deterioration and damage. The logistics system worked reasonably well in Europe where distances were modest. But it could not have supported operations at American scale. One revealing comparison involved ammunition consumption during major offensives. During the American breakout from Normandy in July 1944, United States forces expended over 50 million rounds of small arms ammunition in 1 week. This single week's expenditure exceeded Germany's total monthly small arms ammunition production across all calibers for all services. The Americans could sustain this consumption because their factories produced enough to replenish stocks while maintaining reserve supplies. German commanders could not contemplate offensive operations at such scale because the ammunition simply did not exist. Even if German tactics called for similar fire volume, the logistics could not support it. By late 1944, German ammunition shortages were affecting combat effectiveness across all fronts. Infantry units reported receiving 50% or less of authorized ammunition allocations. Machine gun crews learned to fire single shots to make belts last longer. Artillery batteries rationed shells carefully, firing only at confirmed targets. The Wehrmacht was being strangled by logistics as much as defeated by tactics. The final major German offensive, the Ardennes attack in December 1944, illustrated the ammunition disparity clearly. German forces attacked with carefully hoarded ammunition reserves, knowing that resupply would be minimal. American forces defending the Ardennes had access to effectively unlimited ammunition. German attacks bogged down partly because American defenders could sustain defensive fire that exhausted German assault formations. The examination of American ammunition continued even as Germany's situation deteriorated. Technical intelligence teams still analyzed captured supplies, still wrote reports, still documented the gap between American and German capabilities. The reports became shorter and more pessimistic, but the technical analysis remained professional and accurate. One report from March 1945, written as American forces crossed the Rhine, provided a final assessment of the ammunition situation. Germany had lost the industrial war completely. American ammunition production exceeded German production by factors of 5 to 10 depending on caliber. Quality gaps had widened rather than narrowed. The Americans had won the ammunition war in factories years before final military victory was achieved. The report noted that German soldiers were recovering American ammunition from battlefields, carefully collecting cartridges from American casualties and abandoned positions. This ammunition, fired in captured American weapons, often provided German units with more reliable firepower than their own supply systems could deliver. The irony was bitter, but undeniable. The human cost of ammunition scarcity appeared in reports from frontline units. German soldiers described holding fire against targets they could have engaged because they lacked ammunition. Machine gunners reported watching American formations advance while conserving their last belt for desperate close-range defense. Infantry companies attacked with each soldier carrying 30 rounds, knowing that resupply would not arrive before the engagement concluded. American soldiers, in contrast, reported throwing away partial boxes of ammunition rather than carrying extra weight. They left opened crates at positions they evacuated because new ammunition would be available at the next supply point. They fired at suspected positions, unconfirmed targets, and harassing fire missions because ammunition was treated as an expendable resource rather than a precious commodity. The psychological impact of ammunition abundance versus scarcity affected combat performance in ways that transcended pure firepower. American soldiers fought with confidence that their weapons would not run dry. German soldiers fought with the constant mental calculation of remaining rounds and uncertain resupply. Confidence affects aggression, initiative, and willingness to engage. Scarcity breeds caution and defensive mindsets. The examination of American ammunition also revealed the infrastructure behind manufacturing that Germany lacked. American factories had access to unlimited electrical power from hydroelectric dams and coal-fired plants, They had skilled maintenance workers who kept machinery running continuously. They had transportation systems that delivered raw materials and removed finished products without interruption. German factories operated under increasing constraints. Electrical power was rationed and unreliable due to bombing of generating stations. Maintenance workers were conscripted, leaving machinery to deteriorate. Transportation systems were crippled by Allied air attacks and fuel shortages. The infrastructure that enabled mass production was crumbling under strategic bombing and resource depletion. By April 1945, German ammunition production had essentially ceased. Factories were captured, destroyed, or cut off from raw materials. The examination teams that had spent years analyzing American ammunition found themselves without subjects to study. The final reports documented not technical specifications but the complete collapse of German ammunition logistics. The last technical intelligence report on American .30 caliber ammunition was dated April 23, 1945, 1 week before Germany's surrender. Written by one of the few remaining analysts still at his post, the report summarized 3 years of examination and assessment. The conclusions were unchanged from the first reports in Tunisia. American ammunition manufacturing represented industrial sophistication that Germany never matched and could never have matched with available resources. The analyst noted that every prediction made in early reports had proven accurate. American production had increased rather than plateaued. Quality had improved rather than degraded. American infantry tactics had evolved to exploit ammunition abundance more effectively. The gap between American and German capabilities had widened throughout the war rather than closing. The report's final paragraph reflected on the broader implications. Ammunition, the analyst wrote, was not merely a technical product, but the foundation of modern infantry combat. The side with more ammunition could afford to fight more aggressively, take more risks, and employ tactics that assumed firepower superiority. The side with less ammunition fought cautiously, conservatively, and ultimately ineffectively. Germany's defeat, the analyst concluded, was determined in ammunition factories in Missouri and Pennsylvania as much as on battlefields in France and Germany. The examination of captured American ammunition had revealed this truth in 1942. The subsequent 3 years had merely confirmed what was obvious to any analyst who studied the numbers. Industrial capacity determines modern war outcomes, and America's industrial capacity was insurmountable. The immediate post-war period saw American technical teams examining German facilities, just as German teams had examined American equipment. American investigators found the reports written by Oberst Hauptmann and his teams. They read the detailed analyses of American ammunition manufacturing, the accurate assessments of production volumes, and the correct predictions of tactical implications. American ordnance officers were impressed by the quality of German technical intelligence. The reports were thorough, professional, and honest. German analysts had correctly identified American advantages and accurately predicted their impact. The reports had reached appropriate decision-makers in Berlin, yet nothing had changed because Germany lacked the capacity to respond effectively. One American investigator, Major Robert Jensen of the Ordnance Department, spent weeks reading captured German reports on American ammunition. He later wrote that the reports revealed more about American manufacturing strengths than American analysts had documented themselves. The Germans, examining American products from outside, saw patterns and implications that Americans, working within the system, had not fully recognized. Jensen noted particularly that German analysts understood the importance of standardization, automation, and quality control years before American industry fully appreciated these concepts. The Germans recognized that American ammunition quality was not accidental but resulted from systematic manufacturing processes. They understood that American abundance was not wasteful but enabled different tactical approaches. The German reports, Jensen wrote, should be required reading for American military planners. They demonstrated what adversaries saw when examining American equipment, how technical intelligence could accurately assess capabilities, and why industrial capacity ultimately determined war outcomes. The reports were eventually classified and stored in archives, where they remained largely forgotten for decades. In the 1950s, as the Cold War intensified, American military historians began studying World War II logistics more systematically. The German reports on American ammunition surfaced during this research and attracted new attention. Analysts recognized that the reports documented not just historical events, but fundamental principles of industrial warfare that remained relevant. The reports were declassified in stages during the 1960s and 70s. Academic researchers gained access and began incorporating German perspectives into broader studies of World War II manufacturing. The ammunition examinations became case studies in military logistics courses, demonstrating how technical intelligence could accurately assess adversary capabilities, even when that knowledge could not alter outcomes. By the 1980s, the complete collection of German technical intelligence reports on American equipment, including the extensive ammunition analyses, were available to researchers. The reports filled several linear feet of shelf space in the National Archives and had been microfilmed for wider distribution. Graduate students writing dissertations on industrial warfare mined the reports for insights into how Germany understood American capabilities. One dissertation, completed at MIT in 1987, focused specifically on German analysis of American small arms ammunition. The author demonstrated that German technical intelligence had provided accurate assessments of American advantages by early 1943, giving German leadership nearly 2.5 years to respond before final defeat. The failure to respond effectively illustrated how industrial limitations can constrain strategy, regardless of intelligence quality. The dissertation documented that Germany knew exactly what it faced in American ammunition manufacturing, but could not marshal resources to respond. Building 50 new ammunition factories was impossible while fighting on multiple fronts. Training 100,000 additional workers was impossible when young men were needed as soldiers. Importing copper from South America was impossible when shipping lanes were controlled by Allied navies. The author concluded that Oberst Hauptmann and his team had done their job perfectly. They had examined American equipment thoroughly, analyzed capabilities accurately, and reported findings honestly. The fact that their reports changed nothing reflected strategic realities beyond technical intelligence. Germany could not build the industrial base necessary to match American ammunition production because that base required decades to develop, not years. By the early 21st century, the German ammunition reports were being used in business, schools as case studies in competitive analysis and industrial strategy. MBA students studied how German analysts systematically examined American products, identified competitive advantages, and accurately predicted market dominance. The fact that the market was military and the competition was warfare did not diminish the lessons about industrial organization and manufacturing excellence. One business professor at Harvard used the ammunition reports to illustrate the importance of process over product. American ammunition was not dramatically different from German ammunition in basic design, he noted. Both used brass cases, lead bullets, and nitrocellulose powder. The difference was entirely in manufacturing process, automation, standardization, quality control, and scale. The professor pointed out that companies facing dominant competitors often make the same mistake Germany made. They analyze the competitor's product but miss the importance of the competitor's manufacturing processes. They see what is made but not how it is made. They recognize quality differences but not the systematic processes that produce quality. The German reports, he argued, showed both the value of good analysis and the difficulty of responding, even when analysis is correct. The reports also featured in military staff college courses on logistics and industrial mobilization. Officers studying how to prepare for future conflicts read Hartmann's assessments of American ammunition manufacturing and discussed implications for modern warfare. Would future conflicts be determined by manufacturing capacity as World War II had been? Did precision-guided munitions and professional volunteer armies change the calculus that made ammunition abundance decisive? The consensus among military analysts was that industrial capacity remained fundamental despite technological changes. Modern weapons were more complex and expensive than World War II ammunition, but the principle remained: the side that can produce more weapons and sustain higher expenditure rates has decisive advantages. American ammunition abundance in World War II foreshadowed American precision weapons abundance in later conflicts. The human dimension of the ammunition story received attention from social historians studying wartime industrial work. The hundreds of thousands of American workers, predominantly women, who manufactured billions of ammunition rounds, represented a massive demographic shift in manufacturing employment. These workers, trained quickly and employed efficiently, enabled American ammunition dominance as much as the engineers who designed the factories. German ammunition manufacturing, more dependent on traditional skilled male workers, could not adapt as effectively to wartime labor shortages. As skilled workers were conscripted, quality declined because the manufacturing processes assumed skilled operators. American processes, designed for semi-skilled operators, maintained quality even as workforce composition changed dramatically. One oral history project in the 1990s interviewed surviving American women who had worked in ammunition factories during the war. Their accounts described production line work that was repetitive, carefully supervised, and surprisingly technical despite requiring limited training. One woman who had operated a cartridge case forming press at Lake City Arsenal remembered producing over 8,000 cases per shift and feeling proud that she was helping win the war one cartridge at a time. Another woman who had worked in primer assembly at Frankfurt Arsenal described the careful attention to safety and quality. Primer compound was explosive and dangerous, but proper procedures and good equipment made the work manageable. She remembered that rejected primers were rare because the machines were so precise. The quality came from the equipment and the process, not from individual worker skill, though workers still took pride in their contribution. These oral histories, combined with technical documentation and German intelligence reports, provided a complete picture of American ammunition manufacturing as an integrated system. The system combined engineering design, automated manufacturing, quality control, logistics, and human operators into an organization that produced billions of rounds of consistent ammunition annually. German observers examining American ammunition in Tunisia in 1942 saw the product of this system. They recognized its superiority and understood its implications. What they could not do was recreate it, because systems of such complexity and scale require years to develop and resources beyond Germany's capacity to mobilize while fighting a global war. The story of German technical intelligence examining American ammunition ultimately illustrates fundamental truths about industrial warfare. Technical excellence matters less than manufacturing capacity when conflicts are prolonged. Quality is important, but quantity often proves decisive when quality is adequate. Industrial systems take years to build, but can provide advantages that tactical brilliance cannot overcome. For the German soldiers who searched American casualties in North Africa in November 1942 and counted 220 rounds per rifleman, these truths became obvious. For the analysts who examined American ammunition and documented manufacturing superiority, the implications were clear by early 1943. For German military leadership reading the reports in Berlin, the conclusions demanded responses that Germany could not provide. The examination continued throughout the war because technical intelligence requires constant updating. American ammunition improved continuously. German ammunition degraded under wartime pressures. The gap widened rather than narrowed, confirming original assessments and eliminating any hope that Germany could catch up. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.